9. Can you hear me and see the screen? I better check that out first. Yeah. All right. Thank you, Nathan. All right. So we'll start off. We're going to be looking at volume here. All right. So we're going to do a bunch of volume, but so we're going to look at volume of prisms and cylinders. And what the volume is all about is the amount of space that an object occupies. All right. So it's the amount of space you take up. We're going to be looking at prisms today. And a prism is an object that has identical cross sections. And what that means is that it's like a loaf of bread, a perfect loaf of bread. If you were to slice it a particular way, all those cross sections, slice of bread, would be the same. So if you look at our 4 objects that we're looking at right now, a rectangular prism. So if I sliced it, whoops, any which way, actually, you could slice it this way, or you could go left to right slicing. They would all be identical. There's also a cube. Now, a cube is a rectangular prism. It's a lot like a square. A square is a rectangle, just happens to be a special rectangle. Cube's the same, in which case all the sides are equal. That's the big thing with a cube. So I'll put those little ticky marks there. We also have a triangular prism, which I would have to slice this way, kind of like a loaf of bread, for all its cross sections to be equal. And a cylinder, I would have to, slice it left and right for all those cross sections to be equal. But we do have our formulas. A rectangular prism, we have the volume as length times width times height, where here's our length, here's our width, and here is our height. All right. Again, a cube is the same thing, only it's a special one. So we have, well, width and length are interchangeable. So, and again, our height is all the way up. All right. Now, a triangular prism, again, there's our base, just like a triangle, all the distance along the bottom, our height straight up from the base, vertically straight up to the very top. We have our length. All right, so that's how long the triangular prism is. Here is our cylinder. Again, we're going to use pi r squared. What you can notice is our formulas are a little more complicated than they were previously. All right, so we're going to do a couple of examples here. Let's see here. So we'll start off with, we have a triangular prism here. All right, so I look at my formula, and the formula for a triangular prism is the volume is equal to the length times the width times the height. And again, what I like to do, it's a good practice to do because it saves you getting confused, is I like to write down which is which on my diagram. So I'm going to say 12 is my length, which makes 4 is my width, and the 6 then would be my height. All right, so I'm going to substitute in those values. So I have V equals, my length, again, is 12, times my width, which is 4. So again, I'm just looking at my diagram, which is great because I labeled it 6. Now this formula is great because all I have to do is multiply the 3 numbers that I have. And oops, let me grab a calculator. There we go. So if I grab my calculator, I get 288. Now we got to worry about the units. We're in centimeters, but because we're volume and we're looking up space, space is 3-dimensional. So it's cubic centimeters. All right, so there is a rectangular prism. Again, there's another rectangular prism where each side is 5. I'm not going to do this one. I'm just going to label it there for you. All right, so they're all 5. So that's what, again, what those ticky marks are. 3, though. Here we go. I like 3. Again, we're looking at a triangular prism. So I look at my first sheet here. And my formula is volume is equal to 1/2 the base times the height times the length. So again, I like to go on my diagram and label things. And so again, the distance along the bottom of a triangle or a triangular prism, is your base. There's my height, is 4, and my length is 20. And so I substitute in my values. Now, here's something that I will do the entire time for this unit. I see a fraction. Well, I'm not dealing with slope anymore, rise over run, so I'm going to convert it to a decimal because I'm doing it using for calculations. So 1 divided by 2 is 0.5. I have a base of 10. All right, my height is 4, and then my length is 20. There we go. All right, and if I multiply those numbers, I get 4 of them, I can just multiply them all at once, and I get 400 meters. And again, because we're talking about the amount of space, which is 3-dimensional, it's 400 cubic meters. All right, now here's a little bit of a different diagram here. Again, it's a triangular prism because I could cut this thing and the cross sections would all be the same. And so again, same formula, V equals 1/2 base times height times length. All right, and so I'm going to label my diagram. All right, so I got 4 numbers, right? I only had 3 here, so that was easy. But now we got 4. But again, your base is the distance along the bottom. So my 12 is going to be my base. My height is the distance straight up from that base. So there's my height. And then the length of it. So along the side here, well, there's my 10 is going to be my length. And actually 20 is what's called your slant height, right? The height, but on a slant. But we don't need it for this formula. So we only need the 16, 12, and the 10. All right, so I substitute in once again. Again, a half. I'm going to put it as a decimal. My base is 12. My height is 16. And my length is 10. All right, and then I multiply my numbers, put some units on it, which, by the way, are on the last test, everyone was very good with putting your units down, which is great. And so we have, again, the units are centimeters. We are dealing with space, so it's cubed. So 960 cubic centimeters. All right, now, next up here, we have our cylinder. And again, I'm going to look at my equation here. And the equation for this, a little more complicated again. V equals, how am I going to do this? I just go pi times r squared times height. So I'm going to put, I guess, well, how are we going to do the little 2? Right there. There we go. All right. So again, I need 2 variables, my radius and my height. 12 would be my height. All right, then my radius. Now I look over here, I got a 16, but that is the distance all the way across. Your radius is only halfway across. So my radius is going to be half of 16, which is 8. All right, so now I'm going to substitute into my equation. All right, and again, pi, I just like putting numbers in. So pi is 3.14. I'm going to make it a 3.14. I got my radius, which is 8. And I'm going to have to square that. And times my height, which is 12. Again, I'm going to make sure I put that little 2 in there because it is squared in this formula. All right. But again, you have to follow Bedmas for these formulas. All right. So I've got to do the exponent there. So I got 3.14. There's my pi still. 8 squared, 8 times 8 is 64, and times my 12. All right, now keep going with Bedmas. Now, finally, I can just multiply my 3 numbers, and I'm getting 2011.52. Again, we always got to go to 2 decimal places. And once again, we're talking about space. And so it's cubic meters. So again, you got to watch out here. Sometimes you get the diameter when really all you need is a radius. And again, we've got to follow Bedmas. All right, next up. Another triangular prism. All right, so Had that one before. V equals, we got 1/2 base times height times length. Right, let's space those out a bit. There we go. All right, so I'm going to my diagram. Again, base is along here, so there's my B. Height, yikes, I don't have it, okay. But there's my length, it's 15. So I need my height, or otherwise I can't find the volume. Now, check this out. Inside my triangular prism is a triangle, surprise, surprise. And in fact, it's a right angle triangle. I have this 5 here, which again is my slant height, but that's not what I want. Now it's 8 across, but halfway across would be 4. So here's what I'm going to do. I have a right angle triangle where I'm going to find the height. I'm going to use, and this is from, well, way back, the Pythagorean theorem, where we have a squared, which I'll put it after, plus b squared equals c squared. And let me throw those little 2's in there. 2, 2, and 2. All right, so again, the important one is C, which is your hypotenuse, which is always across from the right angle. So there's my C. The other ones are the other ones. So I'm going to use the Pythagorean theorem here. So I have, let's see, 4 squared, I'll put that in, plus h squared equals 5 squared. And I'll put the little 2's in, because that's what's the Pythagorean theorem. All right, so again, I'm going to do some calculations. And so 4 squared is 16, plus my h squared equals 5 squared, which is 25. All right, I'm going to move this 16 over to the other side. And so, run out of room here, h squared is equal to 25. Because I moved the 16 to the other side, it changes sign. All right. And let's see here, my h squared, 25 minus 16 is 9. And then if I square root both sides, which I have to do to get rid of little 2, h is 3. All right, so we had to do a little bit of extra work there, but now I'm ready to find the volume of my prism. Again, 1/2, I'm going to convert that to a decimal. Again, you can see why I label my diagrams, right? Because I just did a bunch of work. I could have got lost, but now I know. I look back. There's my base. It's 8. My height, we just found that, 3. And then my length, we got 15. Let's see. Bedmiths, well, I'm just multiplying all those numbers. So I'm getting 0.5 times 8 is 4, times 3 is 12, times 15, we get 180 centimeters. And again, what we found was space, which is 3-dimensional, so it's cubic centimeters. There we go. So a bunch of different tricks there, right? You can have all the sides the same. That actually makes it easier. All right, but then your triangular prism, sometimes you can get information that is you don't need, like the slant height. So you got to make sure you watch out for that. Following bedmiths is key, right? When you have the squares or an exponent in your formula, which is going to happen. What else we got? And then sometimes there's information we got to kind of keep going, and use the Pythagorean theorem to find out some more information. All right, so that's day 8. I'm going to go through day 9 also, except for this. In day 9, and the rest of this course, we are not doing pyramids, all right? We are not doing pyramids. So if you see a pyramid in your homework, don't do it. All right, so here we go with day 9. Again, continuing with volume, the amount of space that something takes up. And so we're looking at a sphere, which is a nice ball. And so here's our formula, 4/3 pi r cubed this time, cubed. So you got to multiply the number by itself 3 times. The best part about this formula, though, is that you only need one value, the radius. All right, so let's try it out here. And so find the volume of the following sphere. Well, here's our, I wonder if I can copy that. Let's try it. I have a pointer. Oops. No, I guess not. Oh. I was going to try some. Doesn't work. All right, so here we go. So the volume, well, like I said, the only thing you need to know about the sphere is its radius. Well, here we got it. All right, so again, my formula is V equals 4 divided by 3, 4/3, pi r, and again, this time it is cubed. All right, so I'm going to substitute into my formula. Right, V equals, now again, I have a fraction. I don't know if I can convert something to a number, I will. And so if I take 4 divided by 3, I get 1.33. Again, pi, I like numbers, so I'm going to put in the fact that it's 3.14. And I already know my radius, which is 3. And again, we have to cube it. And again, kind of the same situation that we've had before. You have to do bedmas first, all right? So I got to do this exponent first because I look in brackets. Nothing is going on. No, we're not doing polygon prisms. That's why we're not doing a pyramid, one of the reasons. All right, so I'm going to do my calculations here. 1.33, 3.14. But then I got to do r cubed. And r cubed is 3 times 3 times 3 in this case. So 3 times 3 is 9, times 3 again is 27. So I got to take the number and multiply it by itself 3 times. All right, and so then now finally I'm down to a situation we've had. We multiply those 3 numbers and I'm getting 112.766. And the units again are centimeters. And again, we're looking at space here. Cube. There we go. All right, next up, we got, yeah, you're right. I've got 2 screens going here. Let me try it. I'm going to stop here, folks. Give me a second. Technical difficulties. Nice. All right, let me try it again. All right, we're back in action. Looks like it, right?
Yes.
All right. All right. Here's the best part is that I'm going to do the same example I just did that you couldn't see. But it's the same thing. So I'll show you again. Whoops. Here's my formula up here. 4/3 pi r cubed. All right. So I'm going to do another example. Here's the one I did where I got the radius. I plugged it in. But again, I'm going to do another example. It's the same thing, except for this. So I'm going to write down my formula here. We have the volume is equal to 4/3 pi r, and again, it's cubed. So like I was saying, I know you couldn't see it, but the best part about this formula is all you need is a radius. All right, so see how this line goes all the way across? Well, this is our diameter. And again, the radius is half of it. So half of 10 is 5. All right, so that's the only trick you can get with this formula. And so if I plug in my value here, I get volume is equal to, again, with any fraction, because we're not dealing with rise over run anymore. It's the only time I ever keep it as a fraction. I convert it to a decimal, and 4 divided by 3 is 1.33. All right, I put in pi, which is 3.14. And again, my radius, which is 5. I was given the diameter, but I found the radius, and it is cubed. All right, so again, I got to follow bedmas. All right, so let's see here. Got to do my exponent because nothing's going on in the brackets. All right, so we have, let's see, 5 cubed. That's 5 times 5 times 5. So 5 times 5 is 25, but times another 5, 125. All right, so now I multiply my numbers, and I'm getting 522.03. And we're dealing with meters. And again, we're talking about space. It's cubed. There we go. So that's this twist. Normally you have the radius, but I can't give you the diameter. So that's the twist of this equation. But again, same kind of things where I'm converting fractions to decimals, and again, following bedmas once I get things substituted in. All right, so we'll look at our last shape for today, or well, for now anyways. Here's a little unknown fact. When calculating the volume of a cone, for some reason they figured this out, I don't know how, that a cylinder holds exactly 3 times the volume of a cone, all right, when they have the same height and the same radius. So actually, if you take the volume of a cone or volume of a cylinder and you just divide it by 3, you have the volume of a cone. That's what it's saying. So there's our volume of our cone formula, pi r squared h divided by 3. All right, now we're not going to do this type of question. Scratch that out. But here's our formula, V equals pi r squared. So again, a little bit tougher. So calculate the volume of a waffle cone. Oh, I love waffle cones, yogurt ice cream. From an ice cream store. All right, so again, I'm going to write down my formula here. So I have V is equal to pi r squared h, and it's going to be divided by 3. And that is squared there. So I need 2 variables here. I need my r and my h. All right, now this cone's been kind of tipped upside down because it is a waffle cone. And so here's my base across here of this cone. And so right here would be, because this is a circle here, and I'm going from the middle to the outside, there's my radius. And straight up from the cone, that would be my height. All right, so I'm going to substitute those values in. All right, so again, pi is 3.14. Plug that in. My radius is a decimal there. We got 3.5. And that is squared because it's the radius. And again, my height is 9. And I got to divide that all by 3. All right, so again, I got to follow Bedmus. So I got to do the exponent first here because nothing's going on in brackets. So I got to do that 3.5 squared first. All right, so I have, let's see here. I got the 3.14. 3.5 squared. So 3.5 times 3.5. I got 12.25. So I've got some decimals going on here. All right, divide by 3. All right, so actually now I can figure this all out because again, all the numbers on the top are multiply. The number in the bottoms divide. So I can do this all in one step. So I go 3.14 12 times 12.25 times 9, and then divide by 3. And I'm getting 115.4 centimeters. And again, said this many times, it's cubed. 3-dimensional space. All right, what do we got? Last one. Oh, here's a cone that's right side up, I guess you would say. All right, so again, I'm going to have to use my formula where I got V is equal to pi r squared times h. That's the volume of a cylinder, but there's 3 of them in there, so because it's a cone. So divide by 3. All right, so I look at my diagram here. I got my 12, my 20. Well, again, from the center out to the edge of my circle. Well, there's my radius. What else do I need? I need my height. That's straight up. Okay. And this is what, again, 20 would be called my slant height, the S. Anybody know how I'm going to get my height? How am I going to get this height? What do you think? Anybody got any suggestions?
Pythagorean theorem.
You got it. You got her. So again, here's a triangle. Inside my cone, a right angle triangle. All right, so again, there's my right angle. I have a 12 here, but again, the important thing with the Pythagorean theorem is your C value, which in this case, I guess, is also my slant height. All right, so I have A squared plus B squared equals C squared. So I'm going to have to use the Pythagorean theorem. That's showing up again here. So I got to pick one of these as A and one of these as B. It doesn't really matter. So I'm going to say my height is my A, so that's H squared, plus my 12. And again, my hypotenuse is always the C value. That's the one that has to be different. So it's again, it's across from the right angle. It's 20 squared. All All right, so I do a bit of math here. So I got h squared, 12 times 12 coming up here. 12 times 12 is 144. 20 squared is 400. All right, I'm going to move that 144 to the other side. So I have h squared is equal to 200 minus that 144. And let's see here. I subtract those two and I get, 400, not 200, 400. Fix that. 400 minus 144 is 256. Okay, now again, last step to get rid of that little 2 over here, the exponent. We got to take the square root of both sides. If I take the square root of 256, I get 16. That's odd to get a non-decimal. All right, so all of that work, and now I can finally go back to my formula here, right? So I have, let's see, I'm going to write it out. Let's do that better. So I got my volume is equal to, I got pi, 3.14. All right, my radius, this is again why I label my diagram, because you get sidetracked here doing other stuff. So I got 12 as my radius, and it is squared, times my height, which I had to work for, 16. And then finally divide by 3. All right, following Bedmas, I got to do that 12 squared on the top. And so I got 3.14 here. Whoops, 14 times 12 squared. I had that. 12 squared is 144. All right, times 16. And of course, divide by 3. All right, I can do that all now in one step. So I take the numbers again on the top, multiply. The number 3 at the bottom, I'm going to divide. So I get 3.14 times 144 times 16, and then divide by 3. I'm getting 2,411.52. Again, go to 2 decimal places. We're talking about meters here, and again, it's space. So it is cubic meters. And there we go. So again, there's some tricks there you got to watch, but ultimately we follow Bedmas. Sometimes you got to use that Pythagorean theorem. That showed up a couple times. Is there any questions at all?